Okay, going to go through the Kinematics SAC that you guys set on Thursday, just going through solutions. I'll break the video up into several pieces because otherwise it's too big to go up as one hit on YouTube. Okay, so let's have a look at the first couple of questions. First one, explain using appropriate examples the difference between a vector and a scalar quantity. Okay, so examples, vector, scalar, keywords. Vector quantities have magnitude and direction. These are the two keywords. And an example would be velocity, acceleration, displacement. Any of those is fine. Scalar quantities, only magnitude. So for example, speed, just to keep them consistent. Alright, question 2. Convert a speed of 90 kilometres an hour to metres per second. 3.6 is our magic number to convert kilometres an hour to metres per second and vice versa. So going from kilometres an hour to metres per second, we divide 3.6. So, calculator, we've got 90 divided by 3.6 equals 25 speed metres per second. Done. Over the page. Okay, this one was requiring you to draw vectors onto the diagram. Now, 3 basketballs. This basketball is on its way up. This basketball is at the top of its motion, and this basketball is on its way down. So, you're being asked to draw vectors representing both the velocity and the acceleration. So, well, the acceleration is going to be the same for all of them. The acceleration due to gravity, and it's going to be down. So, we can just pop those all in the one hit. And they're all subjected to the acceleration of gravity, all in the same direction. This one is travelling upwards, so its velocity is that way. This one's at the top of its path, so it doesn't have a velocity. So we can either leave it out or just do v equals 0. And this one, the ball's on its way back down, so it has a velocity on the way down. Question 4, another short answer question. What would Aristotle have predicted about the motion of a 400-gram volleyball and a 4-kilogram medicine ball after being dropped at the same time from the same height off the flybridge here at school? Well, Aristotle thought that the heavier object would fall faster. So it would fall faster or hit the ground first, whatever you like. And as opposed to Galileo, who would have said hit the ground at the same time. Okay, I'm trying to abbreviate the answers here just to keep the ball rolling. Okay, so moving on to question 5. A car is travelling at a constant speed of 100 kilometres an hour. So that's velocity. Constant speed, so it's not accelerating. Constant speed of 100 kilometres an hour. The driver takes his eyes off the road for 0.9 of a second, so our time is 0.9 of a second to read his millways. How far does he travel in this time? Alright. First thing we know is we can't use kilometres an hour, so we need to change this to metres per second. So divide it by 3.6 gives us 27.8 metres per second. Alright, we go to our formula page. One of the formulas I gave you here was velocity equals delta x, change in distance, over delta t, change in time. We know the velocity, 27.8 equals, well, delta x is what we don't know, what we're trying to find out, over change in time, 0.9 seconds. Therefore, delta x equals 0.9 times 27.8, 0.9 times by 27.8 equals 25. So 25, how far does the car travel? This is so it's asking you for a distance, so it's 25 metres. Good. Alright, the last one we'll do for this clip, number 6. The express train from Melbourne to Sydney travels at 110 kilometres an hour. When the brakes are applied, it travels 950 metres before it stops. What's the train's average acceleration? Okay, so it's asking us for the acceleration. Its initial velocity for this bit of motion we're looking at is 110 kilometres an hour, and we know we can't use that, so let's transform this into metres per second. So we divide it by 3.6. 110 divided by 3.6 equals 30.6 metres per second. Its final velocity, well, comes to rest, so its final velocity is nothing. And we also know the distance, so we can do x equals 950 metres. It's in metres, that's good. We can use that. Alright, so now we need a formula. We've got our three knowns here, our one unknown here, so we're looking for a formula that has a, u, v and x. So let's have a look at this one. A, u, v, x, lovely. This will do us v squared equals u squared plus 2ax. V squared, v is 0, 0 squared equals u squared, u is 30.6 squared, plus 2 times by a we don't know, x is 950, okay. So 0 squared, 0, 30.6 squared is 936.4 plus 2 times 950, 2 by 950 equals 1900 plus 1900a. We subtract both 936.4 times from both sides. Gives us minus 936.4 on that side. 1900a. Divide both sides by 1900. We get a by itself, and that's going to be 936.4 minus, divided by 1900, equals negative 0.5 metres per second. Acceleration squared. Okay, alright, we'll leave it there, and the second clip will carry on